Hey, it's Norman Bogram. Let's do a little pointer to pointer to pointer stuff, just as sort of a review in old style C. You wouldn't necessarily do this today with C++, although it'll come up on occasion. The class structure, the class hierarchy makes this pretty much obsolete, but that doesn't mean it isn't out there and it isn't under the covers. So let's go ahead and look at it. Let's look at pointers to pointers, pointers to pointers to pointers, pointers to pointers to pointers. Yeah, you got the message. They're all the same. It's only a single dimension list that those pointers are pointing somewhere. And so let's go ahead and go from there. All right, so let's look at our code. What do I mean? They're still the same. No matter what dimension, it's still a list. Well, let's start with the variable. We're going to define this pointer to a character array. That'll be in the constant segment, but anyway, pointer to Bob is right there. And in our array of pointers here, we can have this as a member, or we can just skip the declaration, which we did up here. We can skip that and just put it right in there. Now, for the purpose of this demo, I'll just put a null at the end of every list. So this first list is people starting with B. And of course, I put two people here, Bob and Bam Bam. People starting with N, Norman and Nancy. People starting with A, Adam and Arnie. And then all people. Now this is a higher dimension here. So where this was a two-dimensional list, all of a sudden we have a three-dimensional list, right? So we're including the list of lists. So we're including B people, N people, A people. Yeah, we're doing that. So, and you'll see if you step back and look at it, it's really no difference. There's a null termination. There's a couple of members. This is pretty much the way it goes after the second dimension. There's only pointers to pointers. I mean, no matter what dimension you're in, you get in a higher dimension where you're looking at everything. I mean, certainly that's a lot of pointers to pointers to pointers there. And then you've got the array, so that's a lot, but it's only a single dimension list here, really. Even though it looks like, and it is a higher dimensional list, but it's also a single dimension list because it's really only pointers. But anyway, so let's write a utility function which will allow us to print. So let's go ahead and do that. We'll do that in our class here. Don't know why I chose to put it in a class. Maybe, I don't know, because it's not necessarily C++ style anymore, but it's just for purpose of a demo here. So let's do a print pointer address. Like I said, we can hammer everything into this pointer list, and we can do that with the C style, with the C style notation here. So where we cast it to a constant void pointer. Oops. We cast it to a constant void pointer. Oh, sorry. My bad. In order to print out the address of the list, we can cast it to a void pointer and it'll print the address. It won't try to reference it or anything or dereference it. So we can create a hierarchy here where at the lowest level we'll print out an item, and our item is actually a string. So we'll print out the address of the pointer and then the string, the contents of that string, the character array. It's C style character array. Then we can have a function in the second dimension here, pointer list, that pretty much calls the other one in a for loop. So it's just going to go through the entire list until it hits that null termination, which we left in there. And then it's going to call the lower dimension. And the same thing in the third dimension, the same loop. It doesn't get any clearer than that, where you are just going until you hit the null, and then you're going to call the lower dimension function. So that's going to call 2. 2 will call 1, 1 will call item, etc. And 4 will do the same. There you go. It's going to go through a for loop. It's going to call to the third, and so on, and so on, and so on, and so on. And in our test script here, we can just add some debugging information, but let's start with this like, where we just have the like and subscribe, and then we can take it to the higher dimension and before we print everything. So let's look at that. So really, ls, oops. Okay, so let's just put it in a.out. Here we go. We've got, like I said, the first one is an array called like. It has 2 members, like and subscribe. 2 strings, constant strings. One has an address F095, F095. The other one has an address F09A, F09A. So there you see where they're coming from. Then at the higher level, when you put this into another array, and this is just another list here, where you have a pointer list, null terminated list. Here's an address of that list, A1200, there it is. And in that, you have the 2 addresses you saw before up here, which are your like and your subscribe. And so that's how you worm it out into the higher, how you back it out into the higher dimensions. And then we can print everything here. We didn't go through all the printing out of the entire set in the higher dimensions. We'll just leave that to the third dimension and the second dimension. But you'll see that it prints out everything in that entire set. And that's pretty much it. All right, I hope that was helpful. If you didn't understand pointer to pointer, pointer to pointer to pointer, etc. Again, this is not something you should be using in C++ at all. You should be using your class structure. But if you stay in development long enough, you will find it. It's especially used a lot in older code where there might be a union in the structure. And so everything is in the same lists, no matter what it is. All right, I hope that was helpful. All right, have a good day. Thank you.